What? Yes.
Can we talk to our table mate?
No, you'll be in rows.
We got a
Okay, yeah, so I think I emailed y'all this. You have a quiz next class. Today's notes aren't going to be on it just because you haven't had time to like let them set in. Okay, but the notes that you're going to want to have organized, your quizzes open notes, is 1A, 1B. That's limits on graphs and then limits from piecewise. Okay, then also 2A and 2B. So 1A, 1B, 2A, 2B. Okay, so it's 4 packets. I'll remind you when we switch to homework though, so that you can kind of pull them out and have them ready to go for next time. Okay? All right, so this is going to be the last topic that you're going to be tested over. Okay, your test isn't until next week. We'll do a full class period of review before you take your test. Okay, so your quiz is open notes, your test is not. All right, let's jump into the notes, please, if we can put Chromebooks away. Okay, continuous or continuity, okay, is going to be a feature of a graph that you can draw without picking up your pencil. Okay, so there are 3 types of functions that are not continuous, or what you would say are discontinuous. Okay, the first one is a removable. Does anybody remember what that looks like? Starts with a H?
hole.
Great. Okay, so give yourself a graph with a hole missing. Okay, that counts as a removable discontinuity. Okay, now if any of you guys are like my freaking high schooler, then he would be like, well, I can draw it. I'm just going to do this and then trace the hole. And then no, that doesn't count. Okay, if a dot's missing, you can't draw it without picking up your pencil outside of little shenanigans. Okay, so this is not continuous, or you would say it's discontinuous. Yeah? Okay, there are 2 other types. Next one is jump. Do we remember what that looks like? Okay, the sides have to go to a different value, right? So we're going to go here. And then here. Okay, this would be a jump. Now, let's talk about the difference between those 2 before we go on to the 3rd type. For which of those discontinuities does the limit still exist? Whole or removable. So I want you to put on here for this one, your limit as x approaches a exists, but your f of a, or we'll put y value below that, is either undefined or at a different number. Now, the way that I have this graph drawn right now, what is it? Is the y value undefined, or it's at a different number, the way I drew it? So my limit's here. Do I have a closed dot elsewhere? No, because I didn't draw one, right? Now, let's say I wanted to. Okay, then put your dot maybe up here. So now this would be the case where I have a limit, but my y value is at a different number. Okay, versus if there's no dot anywhere, then you would say your y value doesn't exist. Good? Okay, for a jump, your double side limit doesn't exist, but can your single still exist? Yeah, so in the graph that we drew, okay, your limit as x approaches a from the left, and your limit as x approaches a from the right might exist, or actually they do have to exist. So take out might. They do exist. Or well, they might. Well, yeah, they'd have to. But they don't equal the same number. Okay, so your left and your rights independently exist and equal something, they just don't equal the same thing. Now, I also want to point out, look at your circle type from the left and the right. Okay, remember, circle type doesn't matter. As you're tracing in towards the dot, it's where it leaves off, regardless of the type of dot. Okay, the third type is going to be infinite, and this is where you have an asymptote. Okay, so give yourself a little graph kind of like this. But then as you get close to where we've been putting our hole and our jump, okay, you're going to make it asymptote. And then we'll say on this side that it asymptotes like that. Okay, and if you want to draw in maybe a little line like that. Okay, and then for this type, your left limit and your right limit might exist, but at least one of them is DNE / plus or minus infinity. Okay, so it doesn't actually have to asymptote on both sides. If one side's an asymptote, it counts as an infinite. Okay, but there's only 3 types, and you already knew 2 of them, and we kind of talked about the third. Okay, now the way that these are classified is that removable is a whole. These bottom 2 both count as non-removable. So you'll see that you have a little bracket here to the side. Both jump and infinite are classified as non-removable. Okay, and then within that category, you have jumps and infinites. Okay? All right, so once you have that written down, go ahead and turn the page. So I'm going to give you the formal definition for continuity. Okay, and then we're going to practice using it on some graphs, then some equations. Okay, these are the same 2 things that are going to be on your quiz next time. Everybody have this? Feel good? All right. Okay, there are 3 parts to check and see if your graph or equation is continuous. Okay, so it says f is continuous at A if and only if. Okay, you're going to give yourself 3 little Roman numerals lowercase. Okay, the first one is that the left and right limits have to equal each other. Okay, so step number 1 is left and right sides have to have the same limit. Step number 2 is that you have to have a y value. Now remember that when you are searching for a y value, what kind of dot has to be there? Has to be a solid or a closed dot. Okay, open dots don't count if you're looking for a y value. Okay, now peek back at your equations or your graphs we drew on the front. Which one of those would have been eliminated based on condition number 1? That the left and rights have to equal each other. Jump is out. Which other one? Infinites are out. Okay, then me having a y value, does that fix number 1? No, because I had a y value and I had a limit. They just weren't in the same spot. So the third condition, okay, is that your y value and your limit have to equal the exact same. Okay, and you will be expected to follow this kind of formal structure on the AP test. Okay, but we have lots of time to memorize it. For your test next week, you'll have a cheat sheet with this already. Okay, so these are the 3 parts. If those 3 conditions are met, okay, then you automatically know your graph is continuous. Let's take a look at number 1. Question says, is the graph continuous at x equals 6? So the first thing you're going to write is this, but instead of an A, you're going to put a 6. So you're going to put limit x approached 6 from the left, and then limit x approached 6 from the right. So we're checking 6. That's why my A is turning into a 6 now. Okay, then look at your graph. At 6, what is the left side limit? We're drawing our line in. Okay, what's my left side limit? 4. What's my right side limit? 0. So if my left side is 4 and my right side is 0, is condition 1 for continuity true or not true? Then automatically you have your conclusion. You don't check steps 2 and 3 if step 1's not good. So for step number 1, you would say these are not equal. Therefore, F is not continuous. Okay, and then the little 3 dots, y'all should have seen that in geometry. That means therefore. Okay, if you don't put that on the AP test, no one will cry. It's fine. All right, let's check the next one. We want to check it at x equals 2. So looking at the second graph, the first thing that you're going to do is identify your left and right side limits. So we're doing x approach 2 from the left, and then x approach 2 from the right. Now remember, these have to come out the same for you to move on to the second condition. So for this graph, as I trace in from the left, what y value am I approaching? Okay, -1 is correct. As I switch to the other side and I trace towards my hand, I'm also leaving off at -1. Okay, that means big equals in the middle, that those are equal to each other. I move on to condition 2. Condition 2 means that there should be a defined y value, which will be indicated on the graph by a closed circle. So write f of 2. And then you can't just say it's defined, you have to give the value. So if I go to f of 2, where is my closed dot? -2. Okay, so conditions 1 and 2 were met. Condition 3 is that the limit and the y value had to equal the same thing, did they? No. So I'm going to state that and then have my conclusion. So number 3, you would say that the limit as x approaches 2 was not equal to f of 2. Now, if you want to restate, this was a -1, this was a -2, you can, but it's not necessary. Okay, because you have the information about it. Okay, so therefore, F is not continuous at 2. Questions on that? All right, when you're ready, go ahead and turn the page. So for the next one, we're doing the exact same structure. Okay, but instead of having a nice, easy graph, okay, we just have piecewise functions instead. Okay, this is a very good review for your quiz next time. Okay, you have a piecewise graph, and we need to know if it's continuous. Well, then write down step 1 or condition 1. What do I have to check first? Limit from the left and they have to be the same. Very good, or equal. So I'm going to put LIM, x approach 3 from the left, then LIM, x approach 3 from the right. Now, if you forgot from the homework where we covered this, for a left limit, you're going to use x is less than 3. And for a right side limit, you're going to use x is greater than 3. So I'm going to put that as a little note here since you get to use these. Okay, use x less than 3 for a left side. You're going to use x greater than 3 for a right side. So for my less than 3, which little shelf of my piecewise am I plugging into, top or bottom? For the left side. Top, because that's where my less than 3 is. So I'm plugging into x squared minus 5. Now it's a 3 squared minus 5. That's 9 minus 5, which is 4. Okay, on the other side, we're taking our 3. We're plugging it into the x greater than 3 piece, which is the bottom. My equation is an x plus 4, which becomes a 3 plus 4, which is 7. So my left side is a 4, my right side is a 7. Is condition 1 met? Automatically, what's your conclusion? Therefore, f is not continuous. Good job. All right, set the next one up. Okay, it's asking you if the function's continuous at 0. So set up your very first condition, left and right sides. Okay, this time we have a top, a middle, and a bottom. Where will I get my left side limit from? Which part of the piecewise? Top, 3 times 0 plus 2. 3 times 0 is 0. 0 plus 2 is what? 1. Silly guy. That's okay. 2 is right. Okay, then for my bottom one, okay, 0 from the right is going to be greater than 0. Which means it'd be e to the x is e to the 0 plus 1. What's e to the 0? 1 plus 1 is 2. So big equals in the middle. Those did equal each other. Condition 1 is met. For condition number 2, what do I have to have? I need a limit for condition 1. What do I need for condition 2? A closed y value, which is going to come from this piece right here. Okay, so this is your y value. It's wherever the equal to is. So for step number 2, I would say f of 0 is equal to 5. Now for condition 2, is it met? Did I have a y value? Yes, it's 5. Condition 3 says those had to equal each other. Will that one be met? No. So for condition 3, you would say that my y value did not equal the limit. Oops, 0. Therefore, not continuous at x. Okay, also be very careful. This should be a 0. Mine looks like an A because I wrote an A. I'm not trying to fix it. Okay, but it's a 0. It has to be the specific number you're checking. Okay. All right, turn the page. You're doing great. Do you kind of get the idea? Okay, we're just gonna do one more. Let's do the bottom one. Okay, we'll skip 5 just to kind of shorten these up. Yes, ma'am.
So
yes, you're gonna look for the equal to. Okay, so we're skipping 5 just to shorten these up. We're going on to number 6. Okay, and if you didn't hear her question, it was if there's not a specific equal to equation, you're gonna look for the y value where the equal to already is. So split this bottom one into 2. Okay, here's what the question asks. It says, is it continuous for all real numbers? Now, the only numbers we really have to check are going to be where you switch from one piece to another. So we're talking about breakpoints here. What are my 2 breakpoints?
0.
0 and 3. So first we're going to check x equals 0. Okay, remember BP stands for breakpoint. And then we're going to check x equals 3. Okay, I want to start with 0 first. So put your 2 limits, left and right. Okay, which piece of the piecewise will we plug into for a left-sided limit for 0? Top, middle, or bottom? Top. Okay, because that's where my less than is on 0. So it'd be e to the 0 plus 4, which is 1 plus 4, which is 5. Okay, now we're doing our right-sided limit. Where is the right-sided limit for 0? We know it's not the top because that was left. Middle is correct because cover the 3. That's an x greater than 0. Now it's written as 0 less than x, but that's the same thing. Remember, the alligator opens towards the bigger thing. So if it's eating the x, x is greater than 0. So we're plugging into the middle. -2 times 0 plus 5 is 0 plus 5, which is 5. So condition number 1, my limits have to equal each other from each side, do they? Yes. Condition number 2, I'm looking for a y value. Okay, remember that y values are closed dots. They could be their own piece in the piecewise, or they could be an equal to on a 0. So looking at your left and right limits, which piece has the equal to? Okay, the top, but we already know that came out to be 5. Okay, so I'm going to put here, use this piece because equal to. All right, then my third step would be that those steps 1 and 2 had to match. They do, so we're literally just going to state that. So my y value at 0 does equal my limit as x approaches 0. Therefore, f is continuous at 0. Okay, but notice we're only really having to check where problems could come up. That's going to be at your breakpoints. All right, do the same thing for 3 right next to it. So you're going to do your left and right sides, check your y value, and then make sure they match. For the left side of 3, can you tell me what piece you're plugging into, top, middle, or bottom? Middle is correct. Okay, do we even move on to part 2? No, your left and rights came out different, you're done. Now, if you did, where's the equal to on 3? Do they have one? Does either one of them have an equal to built in? And it didn't get its own piece. So I'm going to put here also, okay, in step 2, f of 3 is undefined. So this one actually has 2 reasons, okay, that really you could list either one of them as a problem. Unless all 3 conditions are met, it's not continuous anyways, okay? So therefore, not continuous. Okay, any questions? Okay. It's only 9:30. Can we just finish the last thing so we don't have to break our notes into two pieces? Are we good with that? Okay, the last little bit of your homework for today is going to ask you to make equations continuous by finding a particular number that will make the limits equal each other. So look at number 7. Okay, this is the last thing you have to learn. It says find the value of k. So notice we have an unknown number in our equation. That's going to make it be continuous. Well, remember, in order for it to be continuous, the left and right sides have to be the same. So essentially, you're going to just take those two pieces, set them equal at the number that they have to be equal at, which would be in this case 2. Very good. So I'm going to put little steps here. Set left equal to right. Plug in breakpoint. And then solve. Now notice it's not always a K. In the next one, it's an A. Okay, but it could be a different letter, but you're looking for the unknown. So go ahead and write down. We're going to let the left limit, which is kx squared, be equal to the right limit, which is 2x plus k. Now, keep in mind, the left and rights don't have to always be equal. They just have to be equal at the breakpoint. What do we say the breakpoint is? 2. So we're going to plug in a 2 for our at. So I'm going to put here at x equals 2. And then we're going to put that 2 into the x spot. So this is now a k times 2 squared. This is a 2 times 2 plus k. What is that left side going to equal? 4k. Okay, then 2 times 2 is 4 plus k. What do we do next? Yes. Don't move the 4. We want to get our k's on the same side. Yeah, I'm going to minus the k across. So my k's are gone. What is 4k take away a k?
3.
3 k's equal to 4. And then divide by 3. So your k is 4/3. Okay, these will not always on your homework come out to be whole numbers, so just be prepared for that. Okay, try the next one. Or actually, let's skip 8. Let's do 9. Set up number 9.
K also be 0. Oh, no. No.
Okay. Yeah, because that will 0 out your left side. Okay, so we're skipping 8. We're going on to 9.
Sure.
So you're taking left equals right, then you're plugging in the breakpoint. You're doing number 9.
2. It's dividing on 1. No,
And what if the answer was 6 and 7?
so I think
Why
are you so?
Okay, so your first 2 steps are up there. Make sure you put the 2 where the x is, not where the k is. Your left side should have come out to k squared minus 2k plus 1. Your right side, 2 squared is 4 plus another 2 is, we combine those? 6. plus 2k. All right, now I know it's still barely September. Okay, but how do we solve? What do we do? So technically it's a k squared. That means I'm going to get multiple answers, right? If it was just a k, I just get one. I have to factor. Very good. Now, in order to factor, all your crap has to be on the same side. So my 6, I'm going to have to minus over from which number? The like term would be from the 1. And my 2k is going to have to minus from the 2k. So I'm going to write those on each side. Minus 2k here and here. And then minus 6 here and here. Okay, remember, you cannot factor with k's on both sides. So 6 minus 6 is gone. 2k minus 2k. K is gone. You have it equal 0. Okay, for your left-hand side, what is negative 2k minus 2 more k's? Negative 4k, and then 1 minus 6. Very good. Then from here, you would AC chart this, or however your teacher taught you to factor. Okay, so remember how we reviewed it, I think on the very first day of school in that little packet. Okay, is your AC goes on the top. Your basement goes in the bottom. So remember, air conditioner's in the top, basement's in the bottom. Okay, A times C is 1 times negative 5. 1 times negative 5 is negative 5. And then I would list all of my factors that multiply to 5, which is only 1 times 5. Okay, I'll worry about the minus later. Okay, the basement number is what? Negative 4. Then I need to pick partners, which I only have one set, that will minus to give me a negative 4. So I've got to pick 1 and 5. But where will I put the minus so the 4 comes out negative? On the 1 or the 5? Okay, very good. So your factors are k plus 1 and k minus 5, which means that your solutions are the reverse signs of those. So if plus 1 is in the parentheses, then k is equal to minus 1. And then if it's a minus 5 in the parentheses, then positive 5 will be your final answer. Do you get it? Okay, we have to do one more, number 10. Okay, go ahead and start it off for me.
We do it by ourselves.
Maybe just look at it for now. We're skipping the one above it. We're just doing the bottom one on the next page. Don't look at the top one. It's fine. Okay, first question I have for you.
What?
How many breakpoints do you have? 2. What's the first one?
1.
Negative 1, and the second one's at 2. Very good. So you're going to have to create a system of equations. Okay, one set is going to be equal at negative 1. The other set's going to be equal at 2. So I'm going to kind of split my paper in half here. I'm going to let the negative 1 pieces equal each other and plug in negative 1. Then I'm going to let the 2 pieces equal each other and plug in 2. So we're going to set top equal to middle at negative 1. Then we're going to set middle equal to bottom. And hopefully those instructions are good enough for you to know what we did later. All right, so start that out for me. Hopefully you know what I mean. If you don't, ask somebody next to you or raise your hand. So top and middle have a breakpoint at negative 1. Middle, bottom are equal at 2. You can do it. Very last question. So do your top is 2x cubed plus x plus 7 equal to m. Yes, this. So for now, I just want you to simplify it. Put the like terms together and then you're gonna move to the other side.
Yeah, I'm not the one. Oh, that's all class all. And I'm really tired.
Okay, you're not gonna just immediately get an answer. So what I'm wanting you to do right now is just do both sides and then work them down to an equation. A simplified-ish equation, but you're not gonna get like m is 5 yet. Very good, and then combine the right terms. Yeah, correct. Well, you would cube the one first and then time it into 2 circles. Follow your pendulum there.
Oh.
Ready, okay, so then let's see what you remember. Solve this, and then everybody do that, not for 2.
Oh, it's only supposed to work like 4 or 5 hours.
All right, let's keep going, let's keep going. You can do it. You're not done yet.
You can have your 6 7. Which one?
Okay, your left side should look like mine. When you combine like terms, that'd be 4 is 2m plus k. Did you get the left side?
I did, everyone else out.
Wait, did I
What
do it?
about the cube?
So when you cube -1, it's -1 times -1 is +1 times 1 more -1 brings it back to a -1. And then you double it after. So remember, guys, you got to follow PEMDAS. Exponents happen first, then you multiply with the 2. Did you put -8?
Yeah.
That's okay. All right, so if you see what I did there, now I want you to do the same thing over here if you haven't already. So left and right equal, then just kind of work it till you get some m and k stuff. Yes. Say what? So -1 to the 3rd power stays a -1 and then you times it to 2. So it knocks it to
Where the fuck? Yeah, watch your lunch.
Yeah. Now x is +2, correct? Because you're setting the middle and the bottom equal to each other and their breakpoint is 2. Okay, good. Now I want you to solve this one for k and then substitute it for that. Do you remember how to do that from before? All right, so your other side, once you have it, okay, I can't talk in it. So you should have 5m plus k equals 9. Is that correct? Okay, from here, this is a system of equations. Now, when you were in Algebra 2, okay, you learned 3 ways to solve systems. The easiest one, if a letter can be solved for, is substitution. So I'm going to solve this side for k. What will it require of me if I just want k alone and there's a 2m added to it? Very good. So I'm going to take the 2m and I'm going to subtract it across. So it's now 4 minus 2m is equal to k. Then I'm going to take that expression and I'm going to plug it in where k is over here. Okay, this is called solving a system of equations by substitution. So if my K is equal to 4 minus 2M, then I'm going to put a 4 minus 2M in this spot right here. So I'll have 5M plus, and then 4 minus 2M equals 9. From here, combine like terms. What's 5M take away 2M? 3M. Plus 4 is 9. Next step. Minus the 4 across. 9 minus 4 gives me 5. Divide by 3. Your M is 5/3. Now, notice M being equal to 5/3. Okay, that is not my final answer because I need an M and a K, right? But if I know M is 5/3, then now I can come over here, substitute that in, and I'll have my second answer. So K is going to equal 4 minus double 5/3. Okay, so K is equal to 4 minus double 5/3. And then if you don't remember how to do fractions, just put the 2 over 1 and times the tops and the bottoms together. So 2 times 5 on top makes that a what? 10 over 3. Okay, now I can't subtract a fraction from a whole number, okay, unless I make them both like terms. So if I want this 4 to be in thirds, I'm going to times by a 3, top and bottom. That makes my 4, if I times it by 3, how many? 12/3. Take away 10/3 is how many? 2/3. Very good. Okay, so that'd be 12/3 minus 10/3. K is 2/3. Okay? Now, they won't all be that hard, but you will have a couple. Do you have any questions? All right, get out your program books. You want some scratch paper? Perfect. Yes? Yes. Did you already put a pass through? Okay.
We all know. You have like 6 or 7. Oh my God.
So you need to go to the bathroom? Go ahead. All right, I want you to start, okay, with finding K, and I want you to just try, let's do second from the bottom. Okay, so give it a shot. Second from the bottom. Okay, y'all all have the same question here, that it'll make it a little bit easier to find your mistake before you have to do it by yourself.
All right.
Okay, any paper?
For what?
Yeah, just a little scratchy. A little scratchy paper. What do you want?
I'll take it.
Do you have your hand up for a different paper? No. You want any paper? Want scratch paper?
I'll put it all on my.
Or anything like that?
What does it mean by both?
Paper?
I mean, like.
You really want me to? Okay, if you want more, just tell me.
Yeah, I need to like see some.
Trevor, you use the paper, or you good?
Gravity. I'm ready for the weekend.
Yeah.